Most elements have only one dominant isotope. For example, the dominant isotope of hydrogen is hydrogen 1, while deuterium and tritium represent only a small fraction of hydrogen atoms. Similarly, the dominant isotope of carbon-12 is carbon-13. Similarly, the dominant isotope of carbon is carbon-12, while carbon-13 and carbon-14 represent only a small fraction of carbon atoms. In contrast, though, chlorine has two major isotopes. One isotope of chlorine, chlorine-35, makes up 76% of all chlorine atoms, and the other isotope, chlorine-37, makes up approximately 24% of all chlorine atoms. As a result, all compounds that contain a chlorine atom will give a characteristically strong M+2 ion. For example, consider the mass spectrum of chlorobenzene shown here. The molecular ion appears at a mass over charge of 112. The M+2 peak, shown here, so you have 110, 11, 112, 13, 114. The M+2 peak is approximately 1/3 the height of the parent peak. And this pattern is characteristic of compounds that contain a chlorine atom. And so the take-home message for students in Chemistry 3101 is, when you see an M+2 ion that is about 1/3 the height of the molecular ion, you know that you have a chlorine atom in your molecule. Compounds containing bromine also give a characteristic pattern. Bromine has two isotopes, bromine 79 and bromine 81, that are almost equally abundant in nature, 51 and 49% respectively. Therefore, compounds containing bromine will have a characteristic peak at M+2 that is approximately the same height as the molecular ion peak. For example, consider the spectrum shown here for bromobenzene. So I've gone ahead and I've calculated the mass of the molecular ion, which is 156, and that's what we see here. If you take a look really closely, you have 150, 151, 2, 3, 4, 5, 156, then we have 157, and then we have 158. And so the take-home message is, when you see an M+2 ion that is roughly the same height as the molecular ion, that means that you have bromine in your molecule.